Hello everyone. Today let's solve the problem number 200, number of islands, right? So here what the question states here, we are given an m into n grid. M into n nothing but row, which consists of rows and columns, right? So we are given an m into n binary grid. Binary grid means it has to represent either 1 or 0, right? So we are given an m into n binary grid where 1 represents the land. Here 1 represents land and 0 represents water. So that this one you have to keep in mind. 1 represents land and 0 represents water. So an island is formed by connected once horizontally or vertically. So this is very important. We are not considering diagonally here, right? So just give me a second here. Yeah, we are considering either horizontally or vertically. We are not considering this one diagonally. This one we cannot consider. This one we cannot consider, right? So we are considering either horizontally or vertically. Then what we have to do then, and it is completely surrounded by water, and this is completely surrounded by water. An island is formed by connected ones horizontally or vertically and is completely surrounded by water. So what we need to do, what is our main goal then? We need to count the number of islands in the given grid. So we need to count the number of islands. So we need to consider the number of, count the number of islands, nothing but ones, right? That may be connected horizontally or vertically. So we cannot consider the diagonal. This we need to keep in mind. We cannot consider the diagonal ones. We have to consider only the ones that is connected horizontally or vertically, right? So here you can clearly see in this case. So here this is connected. See, horizontally or vertically this is connected, right? Here in this case, if I go like this one till here, this will be considered as 1 actually. So this is connected horizontally or vertically. You can clearly see here. If we start from here, we'll go in this way, then finally here. So this is 1. So the output that we have got here is 1. That's what they have given here. So let's move on with the example 2 here. In this case, so here also we have to do the same thing, right? So here you can clearly see these 4. First here we can move. This one forms 1 actually. This is 1, and we cannot consider diagonally, right? Here this one forms diagonally, but this we cannot consider. So this is one thing. This itself forms another group. This is 1, and these two, this one is connected horizontally, right? You can clearly see this forms 1. Nothing but here 1 plus 1 plus 1 is nothing but here 3, right? So the number of islands here is 3 for the second one. That's what they have given in the output as well. I hope the question is completely clear. Let's discuss the approach first, followed by edge cases one by one, and then finally write the code and discuss the complexities of the code that we have written. Initially, let's go with the approach. So here, let's understand the approach by using example 1 and example 2 that they have given in the example, right? So in the question, sorry. So the approach that we'll be going with here is DFS. Just keep this in mind. We'll be using depth first search. We have solved already many problems using DFS, right? So by this time, we should be knowing DFS and BFS for sure. So this problem, for this particular problem, we'll be solving this one using the DFS, right? So what we'll do, initially, let's start scanning from the grid from 0, 0, from this one, right? 0, 0. And in DFS, we can move either up, we can move either down, or we can move either left, or we can left or right, one step at a time, right? We will start from here. Initially, we will come here down. So first one, when we visit this cell, we will mark this cell as visited, right here. Once we visit and once we find the 1, so what we will do, we will increment the count to 1 here. So we are incrementing the count to 1, right? So So we have incremented the count here to 1, right? So now we have count 1. Now we are performing DFS. We will come here and we will mark this one. So we have found 1 down. This is fine. Next we will come down here. We have found 1, so we will mark this one as hash. Next step, we will come here. So here we cannot go. Even if we go here, this doesn't satisfy the condition, right? Here we have 0. We are checking for 1. Either it should be present in left, right, up, or down. Up we cannot go because it is already visited. The cell is already visited. Here we will go. This one will mark this one as visited. Next step, we will go up. So this one we will mark visited. When we try this one, this fails here. Even though we can go here also, we check for this as well, but here from this one, but this fails, right? So we'll mark this one as visited. Now here if we check, this one fails, but still we'll mark this one as visited. This one here, it is found. So 1 is found, we will mark this one as visited. And here 1 is found, we'll mark this one as visited. And here down we cannot go because it is already marked visited, right? So we cannot go here. So this one here will come. We found 1. This one will be marked visited. Next we will come down. So this one will be marked visited. This miserably fails here because we have 0. We are fetching only for the ones here, right? So here we will stop. In this case, we'll come here and we will stop here because we will check here. This fails, will mark visited. Here also will come. This one, this fails here. This is already marked visited, will not go. Here we will stop. So at one shot here, what we have found here, this one, right? 1 starting from here. So it is sorry, just give me a second here. This one, right? So from here to here, this one, finally here to here, right? So we have found till here. So count remains 1 itself in this case, right? So count remains 1 in this case. So now what we are doing, we are converting all the ones to 0. So once we have c equals 1. So all the cells we have visited, we will convert this one to 0. Sorry, I have showed this one as hash, right? We will convert the cells where 1 was present, right? Where it satisfied the condition. So every cell will be converted to 0 here, right? 0. Now this will be converted to 0. This will be 0. This will be 0. This will be 0, 0, 0. And this one will be 0 as well. Wherever 1 was present, now we are converting all the ones to 0. Now we will continue until all the each cell consists of 0. We'll continue DFS until that one. Now we have zeros in all the cells, or 0 is present in every cell now. So the count will remain as 1 itself, and we will stop the DFS. We don't have 1 anywhere, right? So all the ones are covered here. So we have converted all the ones to 0. So count remains as 1. This is what we are considering as output. So the output is 1. That's what they have given here in this case. So I hope this is clear. This is the approach that we'll be going with. So since there are no more islands are found here, we will just return 1 as output. So that's what we need to get here. I hope this is clear. So let's move on with the second example. Let's try this one very fast. So first we'll come here. So next we will come here. This fails actually. Here we will check for this one. Yes, this one passes actually. This forms one group. So here we cannot move diagonally, right? So we will not be performing this one. So here we will check. This fails. Here we will check. This one also fails here in this case. So here this forms one group here. So this forms one group, right? So next we will check from here. So we will check from here. Here we will check this fails. Here we will check this fails. Here also this fails. This is already visited actually. Whatever we are visited, we will mark this one as hash basically. So this one, this is already visited when we check for the first time, right? This is fine. So this forms another group, second group. So first one, for this one we will increment count by 1. Now we will increment count one more time because we have found one more 1 here. So final step is here, we will come here, we'll start from here because we don't have anything here, right? So this one fails. We have already visited this one, left, right, top and bottom. So this fails. And finally we'll start from this one. This is left, right? So we will start from here. So we cannot go up, this is already visited. We cannot go left, this is also already visited. So either we can move right or down. We do not have anything. Right, we'll move. Here we have found 1. So this forms another group, third group. We will increment the count by 1. Now this is 3, right? 1 plus 1 is 1 plus 1 plus 1 is nothing but 3 in this case. Now what we will do, we will convert all the ones to 0. In this case, this will be 0, this will be 0, this will be 0, and this will be 0 as well. In this case, this cell will be 0. In this case, this will be 0 and this will be 0. So now after converting from whatever the groups that we have found, after incrementing and converting that to 0, we do not have ones in the grid at all, right? So now we will stop the DFS and we will return 3 as output. So the output that they have given for this one is also 3. Right? I hope this is completely clear. This is how we'll be making use of the DFS, right? I hope this approach is completely clear. Next, what we will do, we'll discuss the edge cases one by one. So, first edge case that we are going with here is this one, all water. Here we do not have one at all, right? So here you can clearly see all water means we do not have one present at all in the grid. Everything we have here is 0. Each cell consists of 0 itself, nothing but all water, right? So in this case, count remains 0 itself, right? So for this one, let me give here all water and output remains 0 in this case. This is for the condition all water. Let's move on with the second example. I mean second edge case, nothing but all land. Here we have land, right? Each cell consists of 1. So all land we are considering here. We don't have water. So in this case, we can move any side. So here if I go in this way, this one, we are performing DFS, right? This one and this one. We can just consider the whole group as 1 here in this case, right? This one entirely 1. So we'll increment the count to 1. Count remains 1 itself here in this case. So I'll just give here all land and output will be in this case 1, right? So this is for the condition all land. Then finally, let's come to the third part. Islands separated diagonally here in this case. Island separated diagonally. This is fine. Island separated diagonally means we have diagonal ones, but we cannot consider diagonal. Either one has to be connected vertically or either one has to be connected this one horizontally. So we cannot consider the diagonal ones. So here this will form this will form one group, this will form another group, this will form another group. Each group is different, right? So we have 5 different this one land. So the count will be initially when we visit this one will be 1. Next 1 plus 1 for this one, this is different. So let me do one thing here. Let me write this one here. Count will be when we visit the first one, this will be 1. When we visit this one will be 1. Center one, this will be 1. This one is different, so this one will be 1. Finally this one will be 1. So count will be 1 plus 1 plus 1 plus 1 plus 1 will be 5, right? So we are returning the same thing. We'll convert everything to 0 once we visit, right? So all the ones to 0. So we don't have any ones after converting to 0 in the grid. So we will return 5 in this case. So the output will be 5 for this one. So what are all the edge cases that we considered here? All water, all land, and the final one is island separated diagonally. So I hope all the 3 edge cases are clear along with the approach that we discussed. Now let's start writing the code. So here, let's start writing the code now. So we need a variable that stores the total number of islands, right? For that, I'll just consider this one as count, and initially this one, I'll initialize this one to 0. And let's get the grid dimensions. I'll just consider rows and columns here. In simple terms, I'll just give grid dot length. Right? For the columns, I'll just consider here grid of 0 dot length. This is fine. We are just getting grid dimensions here in this line. So let's move on to the next part. Nothing but we'll be making use of the helper function here because we have to perform DFS, right? So we already saw that one in the examples by considering examples and also in the approach, right? So here I'll go with the parameters grid I and j. This is fine. So the next step is let's go with the base condition. We have to stop if it is out of bounds or on water. So we are not performing, we have to count only the number of ones in the grid or number of this one lands we have to count, right? Or nothing but number of ones, one that is presented. So we have to stop if out of bounds or on water if 0 is present. So for that one, this is base condition. Let's write the simple if addition, right? So I shouldn't be less than 0. So I less than 0 or I should not be greater than or equal to rows. This is one condition. J should not be less than 0 and J should not be greater than or equal to columns. And finally, for water also we are checking, right? Means we are not performing DFS on water. We shouldn't count the water 0. For that one, I'll just write here grid of ij. This one equals 0. Since we are considering this one in the string, they have given here in the form of strings, right? So 0 should be written in the strings. This we have to keep in mind, right? So this is fine. I'll just return. We are not we don't have to return anything in this case. So this is for the base condition. We have to stop if out of bounds or on water, nothing but or on 0, right? So this is the base condition. Next thing is we have to mark the current cell as visited once we visit the particular cell. After visiting the particular cell, we have to mark that one as visited. I showed that one in the form of hash, right? So in the example, while we discuss the approach, by taking the example, I showed the same thing. So this one I can just write in this way, right? I can just articulate that one in the form of code in this way. Grid of ij equals 0. 0 here within the strings because they have mentioned the same thing within the strings, right? So we are considering this one in the form of string. This is fine. Next step, after marking the current cell as visited, we have to recursively visit all the 4 adjacent cells, means left, right, up and down. This one we have discussed. We have solved many problems using the DFS, right? Till now, this one we should be knowing. So let's write the same thing. Means we have to recursively visit all the 4 adjacent cells. So recursive function, this one DFS I'm considering. So parameters are grid I and j I have. So grid, this is for down actually. Down I'll just give here I plus 1 comma j. I'll just copy the same thing here. Let me copy this one thrice. So for down, initially for down we check. So next let's go with the right. So right I'll just give here j plus 1. Let me remove this one. You can go in any order, left, this one, left, right, bottom, up. You can give anything first. It doesn't matter. Order doesn't matter here. So we just have to show that we are recursively visiting all the 4 adjacent cells. That's it. So here I, j plus 1 I'll do. So this one will be I minus 1 for up. And finally, j minus 1. So, sorry. Yeah. J minus 1 for this one, left. Right? So this is fine. After recursively visiting all the 4 adjacent cells, we have to traverse the grid starting from 0, 0, right? So we have to traverse the grid from starting from 0, 0 that we have that we saw during the approach and while we consider the example, right? So here, how can we articulate that one in the form of code? I'll just give here, let I equals 0, I less than rows, and this one, let's increment this one. So next step is for let j equals 0, j less than calls. Let's increment the j here. This is fine. So just give me a second here. Yeah. So so suppose if we have found the one that is attached either horizontally, vertically, this one left or right, then what we have to do, we have to increase the count by 1. That's what we saw, right? So how can I write that in the form of this one code? So I'll just give here grid of I, j, this one is fine, this one equals 1. We are just comparing if it is equal to 1 within the strings because they have asked in the string itself. So count, let me increase this one, count plus 1, or let me do one thing here, count plus, let me give here itself, count equals count plus 1. So if the new line is found, then we are incrementing the count here and this step in the line number 19, this one, right? So next line, the final one is we have to mark the entire island as visited, right? So we have to mark the entire land as visited if it is connected. Here we have only one output is 1 because we are marking the entire island as visited, right? So here we have 3. After checking for all the things, we have to mark entire land as visited. We are converting ones to 0, and once we have all the zeros in the grid, then this one we will stop. We have to stop the DFS, right? So for this purpose, we have to mark the entire island as visited. So how can I write that one? DFS of this one parameters grid ij. I should have copied that one. This is fine. So finally, the last step is we have to return a total number of islands that we have found. We have to return the total number of islands that we have found here, right? So we have to return 3. Here we have to return 1 in this case. So here we are storing that one in the count. So initially itself I said, so we'll be making use of the count variable, right, to count the island. So here I'll just return count. So let me format the code once and let me hit the run button. So we have some error here. Calls is not defined. So here, let's check what we have done wrong here in the line number 17. Just give me a second here. What did I do? So here you can clearly see in the line number 3, instead of this one comma, I have given dot here. So this one is fine. I'll just leave a space. So this one, so it was showing here, this one calls is not defined. So this is fine. Let me hit the run button. So now you can clearly see the sample test cases are getting passed here. So let me hit the submit button. So yeah, you can clearly see all the test cases are getting passed here. So the code works absolutely correct. So let's quickly discuss the complexities of the code that we have written. So the approach that we went with here is DFS. We know that one, right? So the overall time complexity would be here big O of m into n. So when I say it is big O of m into n, we are visiting the each cell exactly once, right? So each cell is here, each cell is visited once. So making it the time complexity big of m into n, nothing but rows and columns. M is rows, n is nothing but columns. So what will be the space complexity here? The overall space complexity would be big O of m into n itself. So just give me a second here. So why here the space complexity is big O of m into n? Because in the worst case, we are making use of the recursion, right? So in the worst case, recursion stack stores all the cells in the island. So making it the space complexity big O of m into n. So we in the worst case, we have to in the memory we have to save all the or it stores all the cells in the island. So the space complexity here would be big of m into n. So the time complexity here would be, overall time complexity here is big of m into n, and the space complexity also is big of m into n. I hope the solution that we have written is completely clear. For now, this is it. Thanks for watching, guys.